Okay, so now let's run through the last part of that problem again, but this time let's assume that we don't have a calculator that will do most of the work. So we check the conditions. We know we're going to do a one sample t-test. We now just have to get all the information and go from there. Now, remember, the information that's needed for a t-test, we need to get a p-value and a t-score. So the t is found by taking the sample mean minus the supposed population mean and dividing by the sample standard deviation over the square root of the sample size. And we're also going to need to know there's a freedom here. Thankfully, the degrees of freedom is just n minus 1. So let's see. The sample mean that we were given in the problem, 5.7 minus the supposed population mean, as divided by the sample standard deviation, which is 29.8, over the square root of the sample size, which is 45. And of course, that means our degrees of 4. Now, even when you are doing this by hand, I suggest using a calculator anyway. We'll pretend that you don't have the Inspire. So the sample mean minus population mean, that's relatively easy to come up with, 27 or 125.7. All right, so our numerator is 10.7. 5 square root of 45 is 6.7082. So we'll do, so our numerator would be 4.4423. All right, so gives us a critical T of 2.409. So our degrees of freedom is 44, and our critical T is 2.409. Now we need to find the p-value, or the closest p-value that gives us that. Now we're using a t-table, and the t-table isn't the easiest thing to navigate. So we know our degrees of freedom is 49. 49 isn't given here, so we'll round down to 40. And we go over until we see something that is as close to 2.409 as we can get. 2.3 is here. It's a little bit high, so we want a little bit less than that. So we are a one-tailed test, right? So it's because we're looking at the greater than side. So we know it's going to be between 0.025 and 0.01. Probably closer to the 0.01 side, right? So that's what we're right. All right, so we know it's greater than 0.01 but less than 0.025. Now, this is fine because our significance level is still 0.05, so all we need is enough evidence to say that it's less than 0.05. Since anything that is going to be less than 0.025 is also less than 0.05, then we would still be good to go. So we'll go ahead and record this. All right, so there we have the information there. So again, based on this information, what can we say? Well, same thing as we said before. There we go. Since p-value is less than our significance level of 0.05, we reject the null hypothesis. Thus, we have evidence to suggest the mean score for college students over 30 is greater than the students in general. Or another way to put that is that the older students, have better attitudes to school according to this attitude test, whatever an attitude test means. And there you go.